Solubility Equilibrium. But first, let's clarify what this topic is all about. This topic focuses on reversible chemical reactions, where reactants and products are never fully consumed. Instead, they are constantly reacting and being produced. On the other hand, solubility equilibrium is a condition involving reversible chemical reactions where solids are dissolved in water to form aqueous solutions. Still confused? Let's take salt and water for example. As we try putting a teaspoon of salt in 500 ml of water, you can see it dissolve over a period of time. This is a process where sodium and chlorine units separate as they get surrounded with water molecules and become hydrated ions. This can be described as this. On the left side of the equation, you'll see the solid form of sodium chloride, and on the right side, you'll see two separate ions, which is the positive and the negative ion. The term aqueous means aqueous, which is a Latin word for aqua, which means water. It is used to emphasize that the ions are hydrated and that water molecules are attached to them. Going back to the example, let's say we radically add more amount of salt in 500 ml of water. You can see most of them going to the solution, but some are going back to its solid form. In other words, it has reached its solubility limit and the solution is saturated. This can now be described by this, noticing two arrows pointing at both expressions, which means the solid and its ions are in equilibrium. This condition might cause confusion since there is a forward reaction where solids break apart and backward reaction where it goes back to its solid form, called precipitation. So how will we know if it actually dissolves or precipitates? That's where the solubility product constant steps in. This represents the level at which a solute dissolves in a solution. In this expression, we can see the solubility product constant of sodium chloride when it's dissolved in water. However, we can get rid of the reactant since it's a solid, leaving us with this expression. Going back to the question, how will we know if it dissolves or precipitates? Assuming we are in a room with a temperature of 25 degrees Celsius, given the fact that the solubility product constant of sodium chloride is 36 grams per 100 ml and that we have 500 ml of water. Disregarding the complicated way of computing for the mass, we will divide 500 ml by 100 ml, which is 5. Then, we will multiply 5 by 36 grams, which is equal to 180 grams. This will result to a solubility product constant of 180 grams per 500 ml for sodium chloride. The value is more than 1, which means it's dissolving. But if the value of the solubility product constant is less than 1, like silver bromide, it means it's precipitating. Thank you for watching. Hope you understand the main concept of solubility equilibrium.